Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 9, Section 2, the Real Numbers System. This is something we've actually previewed before in a previous chapter. I believe it was Chapter 5. We're talking about rational numbers. And during one of those videos, I talked about how the real numbers are a group of numbers that includes pretty much any number you can think of. The only numbers not included in the real numbers group are imaginary numbers, which we're not going to talk about today. You'll typically see imaginary numbers with a little I after them, and it may look like a variable, but it's actually telling you this number is imaginary. So a lot of times you'll see mathematicians avoiding using I as a variable because of that. But imaginary numbers are something for a more advanced class that we're not going to talk about today. Real numbers include any number that you can think of because these are numbers that are real. Imaginary numbers, like I said before, is the reason why they're called imaginary, because they're numbers that technically should not exist. So real numbers are split up into two categories. You have irrational and rational. And the rational numbers category can actually be broken down into smaller parts as well. Irrational numbers are essentially numbers like pi. They're decimal numbers. They have decimals that never end and never repeat. And the reason why they're called irrational is because it just doesn't make sense, because if the decimal never ends but never repeats, there's no predictable pattern to it, then your irrational number technically doesn't have a value because it hasn't found an ending or a repeat yet. We can give a number that predictably repeats a value, because every number technically predictably repeats. Even the number 3, it's a decimal that has an infinite amount of zeros after it. So that's a number that can be predictably valued, and it repeats in a predictable manner. Irrational numbers like pi, we have a computer that's actually calculating pi. I think there are it's over 1 billion numbers in pi at this point. And it still has found no distinguishable pattern, so it's impossible for us to give it a value, because every time you add a new number to the end of that decimal, the value has changed, the value changed again, value just changed again, value just changed again, value just changed again. So the value of this number is constantly changing every time you discover a new digit for the decimal. So this is why these are called irrational numbers, because their decimals go on forever and they never repeat. So their values are constantly changing. Their values may not be changing by much. I mean, when you get to the 100th decimal place, the amount of value you're changing your decimal by is very minute, but it's still changing. So we call those numbers irrational. And the idea is that by calculating pi, I believe that mathematicians are trying to prove there's no such thing as irrational numbers, that some numbers just have patterns that may be billions of numbers big, which is possible, but again, the computer's still calculating pi, so we haven't proven it at this point. Rational numbers, however, are pretty much every other number aside from numbers like pi, numbers that have decimals that don't repeat and don't end. Rational numbers include anything that can be written as a fraction, so in a over b form. Anything that can be written as a fraction is considered a rational number. That includes decimals, negatives, positives, whole numbers, all that stuff. So the groups that we split rational numbers into, there are 3 of them. There are 3 smaller groups. We have integers, which include all of the positive and negative whole numbers. So numbers like -1, 0, and 1, all are integers, and it goes on forever in both directions, negative and positive direction. Integers do not include decimals. Okay? So inside the rational numbers group, you have the group of integers. And inside the group of integers, you have 2 smaller groups known as whole numbers and natural numbers. Whole numbers contain all of the whole positive, the positive whole, all the positive whole numbers. So 0, 1, 2, 3, etc. Again, no decimals. Natural numbers are inside whole numbers. And natural numbers include all of the whole numbers except for 0. So natural numbers include 1, 2, 3, 4, 5, 6. No decimals included, just the whole numbers. But natural numbers do not include the number 0. And the reason why they're considered natural numbers, or another term for them are your natural counting numbers, is because when you start counting, you don't start with 0. No, most people, I haven't met anyone that does it, no one really goes 0, 1, 2, 3, 4, 5, 6, 7, 8. You don't start counting something unless you have something. So if you have something, you have to have at least 1. So these are called your natural counting numbers. So they include 1, 2, 3, 4, 5, etc. No decimals included. And whenever you see a decimal, that number belongs to the rational group, unless your decimal goes on forever and doesn't repeat, then it's an irrational number. Numbers can belong to multiple groups. So for example, as you can see, the number 1 belongs to the natural numbers, the whole numbers, the integers, and also the rational numbers. Like I said, rational numbers are any number that can be written as a fraction. So even the number 1, if you want to write it as a fraction, you put it over 1. Number 5, you put it over 1. 5 over 1 is the way you would write 5 as a fraction. Any decimal you have can be written as a fraction. I did a couple videos on converting decimals to fractions. So if you're curious about that, you may want to watch it. One thing I am going to point out in this video is there are letters to represent each group. The group of integers is typically represented with the letter Z. So if you see someone say the group of numbers Z, they're talking about integers. Rational numbers would be Q. Whole numbers are W. Natural numbers are N. And the irrational numbers, if memory is not mistaken, are I. That's about all I have on the real number system. There is more than just review to this section, as there is a new concept that is introduced in regards to multi-step equations. We will be getting into that. But that actually relates more to Chapter 9, Section 1. I'm not sure why they decided to include this section in Chapter 9, Section 2. But in the next video, we'll be talking about solving equations that have squares, that have squared numbers in them. Or squared variables, I should say.